Hello and welcome to another video. In this video we're going to be working on count nodes equal to average of subtree. And in this problem you're given the root of a binary tree and you want to return the nodes where the value of the node is equal to the average of the values in its subtree. Note the average n of the elements is the sum of the elements divided by n rounded down to the nearest integer. A subtree of a root is a tree consisting of the root and all of its descendants. So we're actually going to take this example here and we're going to go over it in detail. So yeah. So let's redraw it down here and then maybe make it bigger. So we can have 4, 8, 5, 0, 1, and finally 6. And we're going to take this and make it bigger and go over it. Oops. Okay, there we go. So essentially, what we need to be doing in this problem is we need to be computing the average for every single node and all of its subtrees. But the problem is like what should we be returning to get this average? Like let's say we get an average for this node. Well, should we just return the average? Like the average for this node would actually be 3, right? Because there are 3 nodes. So it'd be 3. So if we return 3, then like how do we know what to do with it? Like how do we know exactly what to do? And so what we're going to actually be doing is we're not going to be returning the average. And the easiest way to handle like a cumulative of average is actually not store the average. It's actually you want to store the total and the number of nodes. That way you can take your total, you can add whatever node you want, and then you can divide by the number of nodes and get an average. Now you could do this with an average number of nodes as well. You would have to just like basically do it the other way where you'd have to like multiply the average by the number of nodes and then get the new node and add it and so on, but it's kind of more work. So this is going to be a lot better for us and you're going to see like how it's going to work. So we will have some result and we'll set it equal to 0 because right now we don't have any nodes equal to that. So for any node that's null, we're just going to return 0 and 0 because the total is 0 and the number of nodes is 0, right? And a null node has to be like a leaf node essentially, and it will just be null. So let's just work out like our recursion. And the way we're going to do this is we're going to recurse left, right, and then we're going to get the actual root value, right? Because in order to calculate the total for the entire subtree, we need to get all of the left and the right. So let's kind of work out what's going to happen here. So we're going to start over here. We're going to recurse left. We're going to recurse left. And for this node, there is no left or right, right? So its left will be 0, 0, and its right will be 0, 0. And so now what we need to do is we need to take its left and its right, add the totals. So let's actually write this down. So its left is going to be in the format of total and nodes, and its right will be in the format of total and nodes. And so what we need to do is we need to add these two totals. So we can write that here. So add the two totals. And once we do add, like, so for a full subtree, a subtree consists of its left, its right, and the node value, right? So add the two totals plus node value, and then also add the nodes for left and right and node. So like if the left side had 5 nodes and the right side had 4 nodes, then we would have 10 nodes total, right? 5 plus 4 plus 1. So let's kind of walk through this. So its left is 0 nodes and 0 total, and the node is 0 itself. So here we're going to have 1 node total with a value of 0, right? So remember the average is the total over the number of nodes, and we need to be floor dividing it. So what's the total? The total is 0, and the number of nodes is 1 node. So the average here is actually going to be 0, right? So if the average is 0, it is equal to the node value. So then we will just update our result to be 1 now. And what should we be returning? Well, we should be returning the number of nodes and the total. So here we will be returning 0, or actually the number of nodes is 1. Actually, sorry, it's total and then number of nodes. So total is 0, number of nodes is 1. So we'll be returning up here. Then we will recurse right, and similarly for this part, what is going to be our total and number of nodes. So our total here, because there is no left and right, our total is going to be 1, and the number of nodes is 1. So what's the average here? Well, it's total over number of nodes. So total over number of nodes is going to be 1. And so the nodes value is equal to the average once again. So we will update our result to be 2. And now we'll be returning this up here. So now for this node 8, its left was 0, 1, and its right was 1, 1. So we need to add these together, right? So the total is left plus right plus the node itself. So we have 0 plus 1 plus the node itself. So we have 9. And then the number of nodes is left plus right plus the node itself, right? So there was 1 node on the left, 1 node on the right, and the node itself is 1 node. So we have 3. So the average here is 3, and that does not equal 8. And what should we be returning? Well, we should be returning the total and the number of nodes. So we will be returning that up here. Then we're going to go right. So for this 5, there is no left, but there is a right, so we're going to recurse right. So for this 6, we have a total of 6 and a number of nodes 1. So the average here is 6, right? It's going to be 6 over 1, so that is indeed equal to the node's value. So we have another match, so our result will be 3 now. And then we will recurse up here. And now, so for the left here, the left is 0, 0. And the right is 6, 1. So what's the total going to be here? It's going to be 6 plus the node's value, so 11. And then the number of nodes total is going to be left plus right plus 1 because the actual node itself. So 0 plus 1 is 2. So the average here is 11 over 2, which is 5.5, but we need to floor divide. So that is equal to 5. So this is also a match. So our result will be 4 now. So we will be returning this. So we'll be returning 11, 2, and 9, 3. And finally, for this node, what's our total together? So we have 9 plus 11 plus 4. So that's 24. And then the number of nodes we have is 3 plus 2 plus the node itself is 6. So the average here is 24 over 6, which is 4. And this is also a match. So we have 5 nodes total. So that's pretty much, let's just like write down our steps one more time. So essentially, recurse left and right. For each node, get the total for this subtree and total nodes. Check if total over nodes equals average. And then finally return the total and the total nodes. And that's pretty much all we have to do. So all we have to do is for every node, we just have to keep track of our running total and how many of nodes there are in this node and its subtree. It's pretty straightforward. We can just take how many nodes are in the left subtree, how many nodes are in the right subtree, add 1. Similarly for the total, it's going to be the total for the left subtree plus the total for the right subtree plus the node's value. And that's pretty much it. So not too bad. It's more of like an easy-ish problem. So let's actually code it up now. So we're going to have a result, and we're going to have a traverse function. So remember, if the node doesn't exist, now if you want to, you can avoid having the node not existing by just checking like never go left, or actually no, you would still have to have some value. So I think the easiest thing to do is just say if not node, return 0, 0. And basically the way this works in Python, you don't even have to write array or something. You can return multiple values and it will auto return them as a tuple. So you could write it like this if you want to, but if you just return 0, 0, any one of these works. So we can just return 0, 0. Anyway, so now we have to actually do our traversals, right? So our traversal is going to return to us a tuple of total and number of nodes. So we can say that. So we can say like left total left nodes equals traverse node.left. Same thing for the right, right total right nodes equals traverse node.right. So now that we have a left and a right total, our subtree total is going to be left total plus right total plus the actual node's value. And similarly, our subtree total nodes is going to be left nodes plus right nodes plus 1, because it's however many nodes were in the left subtree, how many nodes were in the right subtree, and the node itself. Then we can just check for the average, calculator, right? So we could say subtree average equals subtree total. And then we're supposed to floor divide here. We're supposed to divide and round down to the nearest integer. So our subtree average is our subtree total over our subtree nodes. And finally, we just have to check, is our node value equal to that average? So if node value is equal to the subtree average, then we want to update our result, so we can say non-local result and result plus equals 1. And finally, we want to return the total including this node and however many nodes were in the subtree. So we want to return subtree total and subtree nodes. Now we just have to call this traverse function on the root and return the result. And that should be it. So let's just double check. Yeah. And there we go. So we have a pretty efficient solution, pretty straightforward. And let's go through the time and space. So as always, for the time for like any kind of tree traversal, it's going to be O of n, because our tree could be completely, or actually, sorry, that doesn't matter what our tree looks like. We're going through every node. So that's just always O of n. But for the space, it is O of n because our tree could be completely unbalanced, right? Where all your nodes look like this. So let's say every node only has like a right child. Then our space for our recursive stack calls would be O of n, because we'd have to basically traverse the entire tree and save it on the stack. So O of n, because it's not guaranteed to be balanced or anything. But yeah, so that's going to be all for this one. Pretty easy one. Hopefully you enjoyed this one, and if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.